We're going to overview a deployment for an Intelligence Fusion Workbench, uniquely leveraging advanced data virtualization. Qplix is a data integration and data management company, and we believe that advanced data virtualization technology uniquely offers capabilities to build an advanced Intelligence Fusion Workbench that no other technology can support. We're going to overview our use case and highlight the technology deployment. Some guidance. Qplix is incorporated in Delaware in the United States. We are a U.S. company. Qplix Corp has patents in various stages of processing to include, but not limited to, the following USPTO documents that are listed. All material in this presentation is proprietary and confidential to Qplix Corp. Qplix Corp is providing explicit guidance such that future releases will include a certified code review specific to satisfying the most strenuous requirements of the U.S. government. Said certified code review may include, but is not limited to, compliance or guidance with the following: FIPS 140-2, NSTISSP number 11, DoD 8500.1 and 8500.2 with a target for protection profile high, and relevant U.S. Federal Information System Management Act 2.0, the basis of definition for a national security system. Let's look at our agenda for this WebEx session. First, we're going to overview the opportunity in context. We're going to share our view of why the opportunity is compelling and why it's essential today. Second, we'll talk about the challenge. What's right and what's wrong with the current approach to intelligent fusion, what works and what doesn't. And third, we'll talk about the future state, how to deploy a multi-domain intelligence fusion workbench using advanced data virtualization technology, the functions, capabilities, and benefits you will derive. First, the opportunity in context. The world today is flat. Every source of information is digitally enabled, and the volumes are exploding. It's unstructured, such as the documents you find in websites. It's structured, such as every record in your databases, and some of it's semi-structured, like XML. The information is here, there, and everywhere. Unfortunately, it's accessible to both white hat and black hat operatives. Everyone is after the same data, and your ability to derive value from the data will define the difference in the world of tomorrow between the quick and the dead. Digital connections are enabled everywhere. Every piece of this data is digitally enabled. Virtually everything is accessible, and there is always a digital fingerprint somewhere in any activity. Even for the terrorist that travels on an airplane and transports data hidden away in a file or a photo and carries it without taking it through an electronic network is leaving a digital fingerprint. They got on the plane. They checked a passport. They may have submitted a print to an iris recognition device. There's always a digital fingerprint, and to the extent that we can catalog them and structure them for our intelligence analysts, we're going to gain competitive advantage and win. The problem is, with all of this data and all of this digital enablement, that there are trees that fall in the forest and we don't know they are there. The biggest gap is not only managing this information, but correlating it to derive value. The opportunity is greater than it ever was. Channels are open. There is more communication between the different capabilities inside our government than ever before. The handcuffs are off. It's no holds barred towards success, but there is tyranny in that trust. Now we're responsible for managing many, many repositories of data and maintaining the tyranny of that trust, the security necessary to access and share all of these different repositories. There's a lot of challenges involved, but the opportunities for success are there. The volumes of data today for intelligence agencies and DoD components are just massive. They span many, many categories, from HUMINT to SIGINT to ELINT to MEDINT, and of course, OSINT, for those of you that don't know, open source intelligence basically means everything else you can find on the internet or wherever you can find it. And it's just a massive, massive amount of data. The volumes are increasing daily. We hear about things like big data, but the fact is that every kind of data is just growing in huge volumes. Systems cannot keep up. Everything is digital. Traditional databases are limited. So if you're using legacy systems, you've got to multiply databases just to span control. There are many new data structures that deal with these environments, such as the NoSQL databases, and they offer greater capacity, but your ability to interface with them and integrate with them is just made much more difficult by the fact that they're all proprietary and different. So there are many new opportunities that remain untapped. Another part of the challenge today is that all of these volumes are siloed. They're siloed by structure and type. We talked about unstructured documents like websites and images that need analysis and tagging for interpretation. And then structured data. Searching databases is actually much more difficult when you want to sift through lots of data and produce a relevant result. There are also silos by organization. We have security permissions to manage and secure transmission to effect. If you use the data from another source or another agency securely and you over a secure pipe, that gives you the benefit of immediacy. If you move a copy of it to your organization, you've created another immediately out of synchronization duplicate data set. And both of these things are happening. Each one has its challenges. And finally, they're siloed by time. So much of this stuff is not real time. It's time sliced into a data warehouse, and a data warehouse is out of date the second it's done. But your terrorist isn't. Your terrorist is making real-time decisions and doing things in the moment to not be found. They're not filing information away in the data warehouse. That's not to say that that information isn't useful, but the notion of information losing its value with time remains true even in this modern world. Finally, there's a huge gap because of the growth in understanding what we have in the data and turning it into knowledge. The gap between data and knowledge is the understanding and the relevancy and the applied semantics, and then we can make it actionable. And without that, we have a gap, and that gap is growing. It's not shrinking. Digital data is exploding, but we cannot process it fast enough and correlate it. If we could, the value could not be measured. The need for speed is imperative. It protects our vital interests, and it ultimately saves lives. That's what this is about. The process today for Intelligence Workbench Fusion is very, very different. Search engines reach into a multitude of unstructured sources. Sometimes they're embedded in custom apps, sometimes special apps, but ultimately there's a lot of search technology that's using unstructured sources, and it is a core component of the analyst workbenches today. It works fairly well with website data or document data and is one of the many workhorses for the intelligence analyst. Structured data is much more expensive and difficult to work with. You have issues over front end. All of structured data is contained within an application, and that application presents a view to it. Or you're just navigating tables and trying to understand what's in there. So what is the front end? Is it a specific application? Many DoD contractors have built many unique applications for knowledge management across a variety of intelligence applications, but they're all different and unique, and the underlying data structures are not easily shared. Are you using search on top of structured data? It doesn't work very well. Are you using BI? It works well, but the setup is tremendous and it can only span to a few data sets. The big issue to step into the technology is the issue of candidate keys. How do you correlate pieces of information to know that these pieces of information relate to one critical event? What is the key that lets you link these disparate pieces together? That's very hard to define and very hard to align the data with. But there's so much valuable data. Structured data may be among the most valuable data components you have in your organization. Finally, notwithstanding your ability to handle unstructured and structured data, the correlation of the two is even weaker than either one alone. So when you try to use a search front end to correlate unstructured results with structured results for any kind of significant effort, the results are useless because of the volumes and because of the relevancy. Search engines do not do a good job with structured data. We're going to show you why that is, how it works, and how it can be improved. So the problem today with structured data is also in the diversity. We have legacy relational applications where the data is accessible directly to the database tables or through APIs. It is not the case that all of your data will be in custom apps. Much of your data will be in commercial applications. There may be incredible value in having access to many large SAP systems and knowing the status of orders, customers, and shipments for components around the world. Likewise, the new NoSQL apps are being used to store considerable amounts of scalable data, and access and integration with these new database types will also be critical. And finally, while there are commercial clouds, there will also be private clouds and custom object APIs, and all of these are things that you need to deal with. The analyst problem today with structured data is pretty clear. Intelligence analysts that use a Google or Lucene front end or any search engine front end are generally ineffective on a broad scale with structured data. It doesn't work very well, and we'll dig into that. The alternate approach is that you have an analyst that has access to every application system you think might be relevant, and they use the actual application front end and the embedded search there. This is impractical but ineffective. The notion that you can have someone on tap when you need them all the time to log into any given application system and to be skilled with the front end of that system to find something you need is very, very unlikely. The third approach is to aggregate clusters of data structures as keys and then try to use a BI front end, which is expensive, limited, but can be effective for small data sets, but not very large data sets. So the interface of choice for intelligence analysts is probably search, but the effectiveness of the interface of choice drops as you use structured data and as you scale the data sources upward. Now, if you really looked at this problem and you tried to figure it out and you said, what's going on inside my search engine that it can't support the structured data? You have to first look at your structured data. Your structured data has, in this picture, all of the relationships that help provide meaning. Those links between tables, one might be company, one might be purchase orders, one might be shipment destinations, one might be product type. Those links are essential to finding the things that you need. You may want to find what company shipped in the month of April over 400 pounds of this particular metallic alloy. And the way search engines connect to structured data today is they give you back all of the companies, everybody in that month, everybody that bought that alloy, and they give you those things at almost equal relevancy. They take every row of data in every one of those little tables you see, and they index it or treat it perhaps like a document. And the problem is that the power in this database is in the lines that link these things together, those relationships. And most of those links are lost. The database applications structure numbers or keys or secondary keys that help each table point to the next so that the application can pull these pieces together. But the search engine with the structured data connector has no ability to process that information and save the relevancy and save the semantics. So the return data is voluminous and hence useless. The rows and rows of similar relevancy with each term further make the data useless, and to be effective in Intelligence Fusion Workbench, you must have a surgical strike to specific data or your opportunity is lost. This is where advanced data virtualization makes a big difference. Advanced data virtualization is a new technology, part of the wave of virtualization that has impacted storage, servers, desktops, and applications. But now we're separating and virtualizing data from the applications that contain it. That makes it much easier to use and redeploy and to use with things like enterprise search. It is Fusion ready, it is intelligence analyst ready, and our persistent metadata server can reach into all of those different sources securely, object, relational, through APIs into applications like SAP or anything else. And our workbench converts all of this into one equal playing field so that the business analysts that you work with and the intelligence analysts are working with objects on our dashboard. They don't have to know anything about the connectivity to the underlying sources. They see objects of information and they can work with those. So it's a very powerful capability set beyond any other technology set available today. There is nothing like advanced data virtualization. If you really had to look at the secret sauce, but please note, patent supply, all rights reserved. When you look at the structure on the right and your search engine goes ahead and uses a primitive connector and indexes every row that you see there like a document and really loses the relevancy of those links, the advanced data virtualization system reaches into these sources, automatically extracts the metadata, and preserves these relationships. We convert that database into a tree structure like a website. Search engines work great with websites. Search engines don't work very well with relational tables or object hierarchies that are not defined in ways that they can digest them. So we convert all of those related tables into objects and represent it as a website hierarchy. And now the search engine can do an incredibly good job of indexing the data and presenting it to the intelligence analyst. This is a huge change to the effectiveness of search technology because now we've coupled Lucene or Google with the capability of advanced data virtualization. Advanced data virtualization and data fusion work as follows. Our application software blades reach into all of the different sources and extract the structure and relevant security information from those sources as we are permissioned. Anyone on our system, any analyst you have on our system, not on the search engine side, but on the configuration side, is permissioned by whatever protocol you use. So for example, if it was LDAP and this intelligence analyst could only get to 10 database sources of, on a specific list, then that's all they would see in our system, that's all they could reach you, and that's all they could materialize in any way or form or search for. Likewise, another analyst might be empowered to see 50 sources. Two, they can now reach into the sources, discover and organize the data, and expose the structure of the data. So you might have one database with Humint, another database with Sigint, and now that data is virtualized and now structured back into a website view so that it can be indexed by the Google Enterprise Search Appliance or by Lucene. So we've taken all of the structure and all of the relevancy, converted those relational entities or other entities to objects, and preserved that structure so that the search engine can benefit from it. The dashboard that we use inside our system, not for the analyst that's using search. Here I showed a commercial screen with commercial apps, but all of these different apps, Salesforce is using an object API, PeopleSoft is a relational legacy app in a data center, and so on and so forth. But all of these things are converted to objects at this level where you can see the metadata and work with the objects. So your intelligence analysts have an equal playing field to work with what may be dozens and dozens and dozens or hundreds of data sources. These application software blades obfuscate away all of the technology that would slow you down. You don't need to know about the programmer's API to get into source A or source B. If there is no API, you don't need to know why DB2 is different than MySQL or Oracle. All of that is transparent to the intelligence analyst setting up the source connections. All they need to know is the permission, the security permission, and they have to be given an LDAP permission or equivalent on our system, and then they are enabled to the source, and then all of the data in that source is exposed. Now, if you're using a system like SAP, you can get to the data from the SAP dashboard and see it through the screens. If you're using a system like ours, you don't need to know anything about the SAP dashboard, but you will certainly find ERP data through our dashboard, customer data, shipment data, and all the things you need to effect integration or to support an Intelligence Workbench Fusion search. So this is how the scenario might look. Now you have your intelligence analyst who's reaching through Google to all of that unstructured data someplace else. But now through Qplix technology using advanced data virtualization, all of these structured data sources are now accessible with all of the relationships in them that make the data most useful, And it's with surgical strike capability through the search interface, which is most comfortable for your analysts and your intelligence knowledge workers. So this is a big sea change. Now you can merge results from unstructured data with results from structured data and not have clutter of mostly irrelevant hundreds to thousands of rows of structured data extracted from tables. Now you'll be able to get one link that you can navigate because you're working with the objects as they are represented in that tree structure. It's a powerful sea change, and it changes the way intelligence information can be brought to the workbench for Fusion. Virtual views into data sources also allow some other very special capabilities. We won't go too far into it today, but you have the ability to add tags to the structured data called virtual fields. These go inside a dictionary, a data dictionary. So if you're the analyst working inside our system to connect to sources, you have the ability to tag data. So suppose you're looking at 87 sources, of which 75 are not in your organization. In fact, there are 9 other organizations. But you need to work with that data, and you need to tag it and use it in different ways so that you can refer to it later, so that you can see how the relevancy and utility and semantics of that data and value to you will change over time. Some information that you think is suspicious today may be incredibly important in 3 weeks, but you don't know until the 3 weeks pass, and you still need to add the value of what you've discovered today. So inside our data dictionary, whether you own the original source or not, in your view, you can augment that structured data. So in organization A, you can augment your access and view to structured data you're getting from organization B. It looks like you're adding a column to their table inside that application, but it's unknown to them. It doesn't affect their application at all. It's virtual. The virtual field is in your view. It's a virtual construct, but it doesn't affect the source data. Yet, it can be empowered through the same search interface, and then incredibly wonderful things can happen. Let's take a look at how this comes together. So first, now we're not going to look at it from the search engine perspective. We're inside our system setting it up. So someone different is going to do the setup and the analysis. So first you're going to connect to all of your sources, whatever they are. Maybe there are dozens and dozens of ERP systems and relational databases and other proprietary structures. Maybe a couple of NoSQL data stores. And the basic interconnection is the security permissions you need. And then those application software blades, which are pieces of software, virtualize the data, provide a secure connection, and extract the metadata into our system. We do not extract any of the underlying data. We let you see it, we let you work with it, but we don't cache big copies of it. We don't move rows at a time. We're only storing the metadata so you can navigate back and forth. Once you're in a system, now you can see all of the structures in that system. In an object-oriented application, you could think of those objects. For most of you, you work with relational entities. Think of them as tables. Here are all the tables listed in this application on the left. And now I can drill into a given table and see the fields. Now that field name, where you see here in blue, they're vertically oriented, but think of them as a table. They're actually listed left to right. And now you're exposing everything in that system. Now look over here and notice that 2 of them are virtual. You may be logged in and permissioned in organization A's database, but you're in organization B, and you've added virtual fields to augment that data in powerful ways. And organization A doesn't care that you've done that. Organization A doesn't know that you've done that. You've compartmentalized your ability to add other value, yet you're still sharing and accessing the data that both organization A and B have agreed to share. And that works vice versa. You can share that data in a data dictionary by user, by group, or by enterprise or entity, let's say by organization. Now there's something else you can do that's very interesting. You're on top of this data, and you can start to build a label. Suppose you're working with 30 data sources and 25 are not yours. And a lot of the field names are cryptic or may not make sense, but as you've examined the data, you've decided that there's some commonality across multiple sets. You may choose to give certain tables or certain fields in disparate systems a common label, or a label that corresponds to a taxonomy or catalog that you've built in your organization. Every time you go to look at that data, you're going to see that capability. Every time you look, but you haven't affected the source system. We're just beginning to touch upon the power of advanced data virtualization here for Intelligence Fusion. No other system can do anything like this. Now we're going to add a virtual field. You can see how that's done. You pop up the field, you decide how is it being done. I'm going to put a value right in there in every single element in the database, or I'm going to build an expression from data that exists. I'm going to concatenate some fields, or I'm going to calculate some fields. It really depends on what you want to do. And I'll give you a specific use case in a minute. Then you can actually drill into the data catalog. So here I am. I'm in my system. I've only got 5 databases locally, but because of security permissions and my secure tunnel, I'm accessing a database in another enterprise's domain, and I can actually go right into the data here without an application. I'm just looking at the tables of data, the structures of data, and it doesn't matter what the structure is in the source database. We make it all look the same. There it is at the bottom. And now I can start to manipulate even my view for how that looks. Here I am looking at a specific data element in that table, and I can sift through every row of data, yet the data isn't in my system. It's only there for the instant of a view. And if you look here, some of these constructs, if we go back, were virtual fields. So first, account designator and financial viability were fields that we added. And I populated, when I set these up myself, I put a 1 in there. I just stuffed a 1 in there for point of discussion. And so now I'm navigating data elements in a database I don't own, where I've augmented the fields of the data, and I've actually put values in because it suits my intelligence analyst activity, but the other people don't know. And likewise, they can do that to me. So this gives you an incredible ability to build out complex and valuable information structures. It lets anyone else higher up the food chain at the highest levels of government access all of this semantic content from all of these different organizations and perhaps derive even greater value from it. It's a very powerful capability. So let's talk about this some more and think it through. So here's an example where, think about that view we saw before, right? So here, in the view here in the system, you see in the lower left here, you see all of the fields, and let's just call this a table. It's actually, this particular application is object, but it doesn't matter. You see it all the same. So here's this table, and here are the fields in the table listed vertically. So here, think of it more logically, list them horizontally. It's a table with information, rows of data, terrorist ID, code word, intercept, base ops, geography, and threat level. All of that metadata is exposed. You can see it, and you can drill into the data. It isn't in your system. It's in another organization's system. And this data might require a special application written by a defense contractor that only they have in that other organization because it's $50,000 a seat. But you can still get to the data, and you can still look at the metadata and expose it in this way, even though you don't have the front end, right, and the application. So here we are looking at the metadata. If I go in and start to look at the data catalog, I can see there's event IDs, there's code words, and then there's other pieces of information, intercepts and base ops, and I haven't tried to fabricate too much here, but I think you can get a sense of what's in there. So now I'm looking at the structure in the data, in their application. I'm not using the application, but I'm sifting through the data, and this data and all the relationships it has inside their application get indexed and turned into a tree structure by us so that the search engines can use it. Now, I want to create a virtual field. So if you think about intelligence planning, you have a consumer that needs information, and then plans are put together, collection goes on, there's processing and exploitation and analysis and production, right? So For my consumer, for something I'm doing in my organization, I want to show these various stages. So here I am looking at this database that I'm sharing, I'm accessing securely, and I've created a virtual field in my view that only I see when I look at this database. It doesn't exist in that original database, and I'm populating it with certain pieces of information based upon my perusal of their data in this source. And that virtual field now has perhaps the stages of analysis: planning, collection, analysis and production, processing and exploitation, whatever is appropriate. This is just a brainstormed example, right? But the idea now that another analyst doing a different kind of work on a source can be looking through the data and perhaps tagging the information. And now the analyst on the other end, who's dealing with current events, that comes in through a search front end, is going to get the benefits of that tree structure that your organization has built with the content from the virtual field linked into that tree structure. So you're accessing a database from organization A. You've added a virtual field based upon your analysis and other field work that you've done, and you're in organization B. And now that virtual structure has been turned into a tree structure and indexed by Google, perhaps for organization C, where the benefits of all of this are immediately visible and highly relevant. The other benefit is you're not taking an out-of-date version of the data from organization A. You're not taking an out-of-date version. You're not taking a time slice. You're right on top of the real data. So if organization A an hour ago has put new data in there, 2 hours later, when organization C does the search, they should be able perhaps to get the benefit of that current information. You know, the need for speed is imperative, right? The speed to understand the semantics of the information and make actionable decisions is the gap between the quick and the dead in the modern world. And we have to move faster than the terrorists that would seek to exploit us. We have to be able to take disparate pieces of information as this information explodes and understand the relevancy of it, understand the semantics, and then know how to make it actionable. Advanced data virtualization gives you a tool set that you can't get any other way to do this. And it allows you to scale it up broadly across many different data sources to uniquely add valuable components of data and then present it back to an analyst through a search front end. There's nothing quite like this technology deployed this way. Thank you for spending time with us today. For more information, please reach out to sales@qplix.com, and we'll be glad to discuss your specific applications.